let's have fun now and let's expand our project to something a little bit more realistic. We can probably try to implement a parking backup sensor system. So we're going to put a bunch of ultrasonic sensors on the back of your car, and as you are backing up, the sensor is going to detect objects and make some noises or blink some LEDs. So pretty much like these are the sensors that you have over here. They're slightly different than the ones that we're using. They have the sender and the receiver installed on the same sensor instead of two separate ones. So notice here that one of them is the sender, another one is the receiver. For this type of system, this is the sender and the receiver. Well, let's have fun with this and let's see if we can do a prototype code here for our parking backup sensor system. So the first thing that we're going to do is design. We're going to design the block diagram for the system that we want to implement. We can start with the one that we had it originally. So we had the Arduino that connects to your PC over USB. If you guys don't remember this part, you can always go back, and pretty much I'm replicating what's going on over here. Arduino and how do they call? They call the HC, so let's call HCSR04. All right, let's go back here. This is my sensor. A couple of pins connected to this one. We have pin 12, pin 11, and then we also have, to minimize the amount of pins that or wires that go around, connect the wire here. And I know I have 5 volts that need to be connected to the 5 volts on the Arduino. Makes your design cleaner. I don't remember, let me just confirm. Pin 12 is the trigger pin. We can give that information too. We can go here and say this is the trigger and this is the echo. Perfect. This is our original block diagram and schematic all together. There are no components connected to it right now. And our system, our parking system, we said that we want to have some sort of noise going on. So let's put a speaker, and we also want some sort of LED. So I added, let me point out what I added so you guys know. I added this part here, the LED and the speaker, to the Arduino. Those are the add-ons to our system. Cool. So now let's see what else can we do here. That's pretty much it. Actually, our LED, we can improve the LED. We already know that. We already know the symbol for the LED, and we already know that an LED needs a resistor connected in series. So actually, let's design our LED properly. Symbol for the LED, our resistor, so remember, for an LED, this is the plus, this is the minus. As long as the voltage on the plus is higher than the minus, the LED will turn on. So our Arduino pin will take care of that. So let's pick a pin for our Arduino. 11 and 12 are being used already. Let's say that I want to use pin number 2. So I'm going to use pin number 2. I'm randomly assigning that pin. And now for our speaker, let's see if we have projects that can help us with that. So if I go to the PDF and I go to the beginning of the PDF, I know that we have a passive and active speaker here. So let's see, here we go, passive buzzer. So let's press passive buzzer, connects to pin 8 and ground. Let's use this one. Let's fix our block diagram. We're going to use that passive buzzer. So let me improve these. Passive buzzer and pin 8 and also connected to ground. Alright, cool. This is going to be the block diagram for your system over here. Arduino, the sensor, the buzzer, and the LED. Alright, we're going to use the passive buzzer from the box. So let's see if we can find the code for this project and start from there. I already have the project ready to be open, and I already installed the buzzer. I connected the buzzer to the Arduino. This white wire is pin number 8, and then the ground, sharing the ground. So if I compile, make sure that the board is connected, compile, I already add the library too. So I did sketch, include library, and it's the pitches.zip. Alright, done compiling. If I deploy the code, let's see if it makes noise. Okay, let me put the wire there. Here you go. So the way that is working, you have notes over here, and the duration of the note is 0.5 milliseconds. So I'm going to take the wire out so I can speak. So the duration of the notes are 0.5 millisecond. Then the loop is just looping throughout this array of notes over here. And pin 8, notice that there is a comment here that helps us. Pin 8, the respective note and the duration, and then waits another second, repeats this. When this is over, waits 2 seconds, and then repeats the loop again. Let's play around really quick here. What we really want about this code is, let's comment this for loop. I don't want to do all these tones. I'm going to choose the C5 note, so I put 0 over here is going to be the position of this array, melody 0. And let's see if it repeats the same tone over and over again. I'm compiling. Need to wait a little bit. It's still running the code. Previous code, uploading. Here you go. Done uploading. And now it's just doing the C note, which is pretty cool. So we don't need, let's connect. We don't need to have these running like these. We can probably, let's see, let's play around with this one. Let's comment the delay. Let's see if this accelerates here the note. Alright, uploading, code uploaded. Here you go. 1, 2, 3, 4, 5. So it's every second. Let's see which one do I need to play. I can play either with the duration or this guy over here. I'm going to play with these and see if it's faster. Compiling, uploading, and nope. Let's play around with the duration here. Let's say it's 100 milliseconds. Alright, uploading, and nice. Alright, cool. Let's make the duration now a little bit faster. See what happens. Compiling, deploys the code. Way faster. It's getting closer to our application. So let's say now the delay is 200. Compiling sketch, uploading. Here you go. Alright, cool. We can play around with these values. If I go closer to the duration of the note, it's probably going to be continuous. Let's see. Pretty cool. Alright, so I'm going to play around with these values here. One more time, one more experience, just for us to know what's going on. Here you go. Let's do that. 150. It's more than enough. Sweet. So I'm going to reuse this code and putting this code over here. I'm just going to use this part over here and the tone and the delay. So 4 lines of code, which is straightforward. Now let's go over the LED. So I already have mounted an LED with the resistor as we designed in the block diagram. One end goes to ground, the other end goes to the pin number 2 of the Arduino. And let's just use the same passive buzzer here code because it should be an easy one. So I'm going to declare pin mode. So pin number 2 is going to be an output pin. Instead of putting pin number 2, let's apply the same technique as we see here with the echo, with the ultrasonic sensor. I'm going to define over here. It's a macro, and I'm going to call LED is going to pin number 2. Alright, perfect. Now I just need to call LED, it's more descriptive. So pin LED is going to be an output pin, and all I need to do is, throughout these several minutes or several seconds, whatever we put here, is going to blink the LED. So let's turn digital right, let's turn the LED on, and now we need to do a little bit of a trick. So if you do on and then wait and then low, what's going to happen is it's going to turn high, wait, low, but because this is done so fast, it's going to turn on the LED all the time. So a technique that we can do is we have this delay. I'm going to actually delay also, and now the combination within these two delays is going to give you the total that you want to wait. So let's say that my total waiting time is 500 milliseconds. That means that, let's put actually 1000 milliseconds, which is a second. That means that I'm going to wait 500 milliseconds high and then 500 milliseconds low. Let me put this here. All right, let's compile the code. And let's see, I'm going to turn on the buzzer too. Compiling and uploading, and here you go. The LED is blinking at the rate of the buzzer. Let's make it closer. So this is going to be the closest. So 150 milliseconds is the closest. That means that I will have 75. Uploading the code. You guys can always disconnect this wire if it's annoying, the buzzer wire. And here you go. This is if it's very close to the car. Okay, turn off the buzzer for now. And let's go over bringing all this code together with the ultrasonic sensor.